Welcome students, this is Chandan Singh Negi. In previous sessions we have discussed the factorial, right? And today we are going to solve some problems related to factorial. The first problem is, which we have given this one. This is n factorial into n plus 1, that is n factorial into n plus 2 is equal to n factorial plus n plus 1 factorial. Oh, this is n plus 1 factorial, right? So that is a question. Sorry. The question is n factorial into n plus 2, that is not a factorial, is equal to n factorial plus n plus 1 factorial. That has to be proved from the left hand side to right hand side. See, we cannot cancel out this n factorial to n factorial. How to solve such type of problems? Just check this one. Here, n factorial, and this is that is a common. But if you look this right hand side, here this is n factorial plus n plus 1 factorial, which is greater than n, right? The n plus 1 is greater than n. So we can break out this right hand side easily. So let's get the left hand side. Okay, I'm just going to right hand side solutions. This is RHS. We have n factorial plus n plus 1 factorial, right? Now this n factorial plus the n plus 1 factorial can be break down to the n factorial. This is n plus 1 into n factorial. See examples which we have discussed in the last session. If this is 10 factorial is equal to, we write this is 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1, right? So then we can write this is if this is 10 into, we can write this is 9 factorial. This is 9 factorial, right? And we can write this is 10 into 9 into 8 factorial. But this is, we can write this is further 7 factorial, then 6 factorial, 5 factorial. But we cannot write that here if it is 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. We can write this is 8, 9 factorial, right? But we can write this is 8 into 7 factorial. So see this one, this is n plus 1. Factorial means this is n plus 1 factorial means this is n plus 1 into n plus 1 minus 1, the one less. This is see, this is 10 into 10 minus 1, 9 into 10 minus 2, 10 minus 2, this is 8 into 10 minus 3 is 7 dot 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 10 minus 9, like this one, not 10 minus 10. So now this is n plus 1 into n plus 1 minus 1 factorial. The 1 cancel out, that is n factorial. We directly write this is n is greater than n plus 1. It is not in the form of the, this is rational number, irrational number. That is basically this is integers, positive integers. So now see, this is n factorial plus n plus 1 into n factorial. Now take n factorial as a common. So what we get, this is 1. If I take n factorial as a common, this is 1 plus n plus 1 into n factorial. This is into n factorial. This is n plus 1. So this is equal to n factorial into n 1 plus 1, 2. So this is equal to left hand side. That is equal to left hand side, right? So that is hence proved, right? And I hope you understand now this one. This is it's quite easy from the right hand side, and if you want to try it from the left hand side, you can try it. Now, problem number 2. If you solve this is 12 factorial divided by 7 factorial into this is 6 factorial. If we have, what is the minimal form of this one? So this one is See, first check this is a denominator which is nearest to 12. So this is 12 into 11 into 10 into 9 into 8 into 7 factorial. That is 7 factorial. Now, this is 7 factorial. Already we have stop it at the 7 factorial. The 7 factorial denominator already have, and into 6 factorial. So 7 factorial is cancel out. So this is equal to 12 into 11 into 10 into 9 into 8 whole divided by, this is 6 factorial, and now we cannot cancel out it by the factorial. It has to be other numbers. So 6 factorial means 6 into 5 into 4 into 3 into 2 into 1. Now just check this one. 6 to the 12, 5 to the 10, 3 3 the 9, 4 to the 8, and 2 to cancel out. So what is the answer? This is 2 into 11 into 2 into 3. So that is a solution. So it is 2 to 4, 4, 11 4 are 44 into 3, and this is equal to 12, and 12 or 13. So that is the solution. So thank you students, thank you. In next sessions we will discuss the more problem. Thank you.